Okay, today is going to be a second day on graphing, and basically it's still considered day one, and I'm just going to go and clean up a few things for you that I didn't talk to you about yesterday. So I wanted to start with this slide, but I'm going to pause while I pick the next one. Okay, so I'm going to start with this pink slide. I think it's, well, you guys, what page is that for you guys? Page 11? Okay. And I am going to just kind of do a little bit of a review with you. Hopefully you remember which one this is. What did I just graph right there? Sun. All right. And hopefully you remember what that one is. Cosine. Now, that's a pretty terrible cosine graph, but anyway, generally it looks like a big valley like that. Okay, and do you remember what tangent was? Asymptotes, yep. And it goes up like this, and I missed the origin, but there we go. Okay, that's what generally what tangent looks like. Okay, so tangent's definitely different than all the others because it's only got a period of 1 pi, and that means half of it's here, which makes this half pi, and half of it's there, which makes this negative 1/2 pi, or pi over 2. Okay, but the one I'm supposed to graph right this second is cosine. So on this pink page, let's graph cosine. So everybody start, and I like to think of this as you got your 1, you got your negative 1, as that there's kind of 4 parts to these. This first part, I just need to, you remember you're always curving, right? So I need to curve down, and then I need to have another curve that's going to be bottoming out down here somewhere, right? So I'm going to have another part of my curve goes like that. And then the next part is a curve on the way up. But that's different than the last part of the curve because that last part is like topping out. There we go. So there's cosine. And then I'm going to pause for a second while you try to label these 5, actually 1, 2, 3, 4, those 6 spots on the graph. I'll pause while you try that. Again, don't try to do this shifting and stretching and all that kind of stuff up here. Just graph regular cosine to start with. Okay, let's see if you had them. This would be 1, this would be negative 1. That's pretty easy. Again, I'm graphing regular cosine right now. I'm not doing these changes yet. All right, for regular cosine, it ends at 2 pi. And then halfway, I like to go halves, like half of 2 pi is pi. Half a pi is pi over 2. And then the only one that's difficult is this guy in between here, and most of you guys get it pretty quick. It's 3 pi over 2. If you want to count it up, it's 1/2 pi, 2/2 pi, 3/2 pi, 4/2. But that's the same as 2 pi. Okay. How many of you had recalled all of them? You knew them. Okay, good. Those you got to get memorized because for everything we do, we start with that. Then we change it. This is my new amplitude. It's changing. Instead of just going up to 1 and down to negative 1, now it's going to be 4/5. So all you got to do is multiply by 4/5. And since this is just a 1, 1 times 4/5, it becomes 4/5. And this one becomes negative 4/5. Next, this part right here, now just to clarify, I hope you know that's the variable, and that's just the number 3.14. Okay, so do you get that in terms of A, B, C, and D? This one's kind of a strange looking one. Here would be like a normal y equals 2 cosine of 3 theta, and then if you shifted it would be like this, minus pi, and then let's say I go up 1. Here's A in the front, here's B, here's C, and here's D. Okay, that's A, B, C, and D. So in this case, do you get we only have 2 things? We have an A and we have a B. You get it never got shifted in here. So I could put a +0 and a +0. It never got shifted horizontally or vertically. All right, so that's A, B, C, and D. For this problem, this must be A, 4/5. This must be B, pi, which is strange, but it's just 3.14. It's okay. And I could call it pi. And C, just got to get used to the fact that if they're not there, the C and the D are zeros because you've added 0 in both cases. It's not like multiplying by 0 because that would be totally different. All right, so this is 0 and this is 0. And that means my amplitude's 4/5. My period is not 3.14. My period is 2 pi to start with, and then you always divide by whatever the B was. Do you get why they used pi, just to show you something nifty? 2 pi divided by pi, I'm going to multiply by 1 over this number everywhere. Again, why don't I just multiply by pi everywhere? Because you don't trust the stuff that's on the inside. It's not going to be a times by 3, or 3.14. It's going to be a 1 over 3. So I'm going to take all these things and multiply by 1 over pi. And we're going to radically change how it looks because the pi's won't be there anymore. But they're just, pi is really like 3.14, so it really isn't, it's just like dividing by 3. Okay, and it has happens to clean up in kind of an unusual way. That's going to be 2. That's going to be 1.5, or 3 over 2. This is going to be 1. And this, when the pi's cancel, is going to be 1/2. So my new numbering is 1/2, 1, 1.5, and 2. All right. And my new period is 2 pi over pi, but I'm canceling off the pi's, and my new period is just 2. Instead of 2 times pi, which is about 6.28, it's just 2. All right, horizontal shift, none. Vertical shift, none. All right, so there's a good review of what we did yesterday. It doesn't have everything in it. I want to just talk to you about what if I had done a couple other trickier things. Okay, now I'd have an A term of 2, which means my, what's that called then? Amplitude is 2. And I'd have a B term of 3, which would mean my new period wouldn't be 2 pi anymore. It would be changed to 2 pi, what? 2 pi over 3, because you'd multiply everything by 1/3. Then, this is a shift and this is a shift. This one's easy. You just move the whole thing up 7 spots. But this one's the more complicated one, because everybody thinks you just move it over pi, right pi, but you don't. Because, remember the famous saying, if you can factor it, you should. So you go 3 comes out, and you get theta, which could be like an x, minus pi over 3. And how do I know that worked? Because this times this makes 3 pi, or sorry, 3 theta, and this times this makes minus pi. So now, the cool thing is, I'm going to use undo to fix those. The cool thing is now, when you do your renumbering first, you will then move it negative pi over 3. Now, some kids understand this better than others, so it's okay if you miss this part, but I'm going to explain it for the smarty pantses out there. We could have moved it over pi. A lot of people are like, why shouldn't it move to the right pi? It can. But then you'd have to move it over pi first, and then do your renumbering later. Because you remember how your standard order of operations would be that multiply should come first, and so it doesn't. And so you're supposed to then move it to the right pi and then renumber it. Well, we want you to always do your renumbering first. So that's why we want you to factor this out, so that you're forced, normally parentheses are supposed to go first. So since you're on the inside still, all of this is still on the inside, this will force you to have the renumbering first. And when it's renumbered, the distances are different. And so then that makes us move it a different amount. Okay, if you didn't catch the reason why, just always factor it. And then you always do the renumbering before you do the move of pi over 3. Okay? All right, one more thing is what if we have a negative thrown in? Negative sine of 2x, for instance, okay? Well, we'd have normal sine graph. Looks like this. I'm just going to do it super quick. I'm not even going to do the numbering on it. Then this would cause me to renumber it, and instead of ending on 2 pi, I would multiply everything by not 2, but 1/2. And then after I got that done, I would need to remember to do that. Well, that's flipping it. Okay, so how do you flip a function like this? Well, just when it was going up, instead it's going to be going down. The green one is the reflection. Now, this is an interesting point. Do you remember this is one of the things on the sheet? Sine of negative s equal to negative sine of x. Do you get that that's telling you that if you do an inside flip, an inside as in horizontal on the inside, horizontal reflection, it should be the exact same thing as a vertical reflection, and that's true. It's a weird thing about sine. I'm going to continue it a little further over here. If I take sine and reflect it left-right, take that red line and in your head, reflect it left-right, do you get that this part's going to end up over here and it will be the green one? So you can do an inside or an outside flip on sine and it ends up having the same effect. So this negative here, I could just as easily put it here and it would do the same thing. It still flips it up, down. And then along those same lines, what did cosine do? Well, sorry, wait a minute, I got to write the cosine law. If you have cosine of a negative angle, it will equal cosine of the angle. This is one of those things right off the sheet, and that's telling you that if you do a flip, left-right flip, a horizontal flip on cosine, it doesn't actually do anything. It just looks like cosine. Why is that? Because if you take the cosine graph, which happens to have a peak right here, think about just that part of it. That's part of cosine. Cosine would continue on and go like that. I guess I could continue a little ways here. Do you get if I reflect that left-right, it won't actually do anything? All right. Okay, so last thing I wanted to talk about is in the homework, I had you skip some stuff. And so your homework for tonight is going to be basically to go back and do the ones we skipped on the homework. So let's get to that here. Finally. Okay. I had you skip these. I want you to go back and do them. So your only homework for tonight is kind of like a catch-up of ones we skipped. And here we had you skip this bottom one. Notice it's got a negative on the inside. Do you remember that when you do that negative on the inside, it'll be exactly the same as if you had a negative on the outside? A lot of people find the up-down flips of sine to be a lot more easy to imagine than a left-right flip. So, all right. Then in here, this is the type of problem I didn't talk to you about, and I need to, because this is something that you are going to be expected to know how to do. So let's talk this over. I'll do number 86 with you. And I think some of you might not have known what to do on number 90 or number 91. So I'm going to just briefly talk you through what you should have done here. I'm not going to do all of these because that's your job. So if they say cosine of the angle equals this, now normally they give you two sides. Like they'd be saying cosine of the angle is 1/2. That'd be a nice easy one. You could probably draw that with no problem. But they're saying cosine is equal to some weird thing with variables. So here's what you do. Everybody make this triangle right here. I'm helping you to do problem 86. It's part of your homework now. And would you agree that cosine is adjacent over hypotenuse, and yet I only have one side, so I really would like another side, so I'm going to put it all over 1. You can do that, can't you? Just put it over 1. Okay. So then, now, do you get cosine is adjacent over hypotenuse? I have just been told my adjacent side is the square root of 1 minus x squared. And my hypotenuse side was 1. That means you can figure out how to get this third side, which you'll need to be able to figure out that sine theta is equal to x. All right, so let's find that third side. My way of doing these for you has always been that you should take the square root of the other two guys squared. Okay, well, this one squared is just, if you square something that has a square root on it, you just take the root off of it. So then that's 1 minus x squared, because I've already squared it by taking the root off of it. And then this other one is a 1, and if I square it, it's still a 1. And now with these two being a hypotenuse and a leg, should I subtract or add in here? And which one's bigger? Which one's bigger, 1 or the square root of 1 minus x squared? Well, because the one's a hypotenuse, it's got to be bigger than the other one, right? So I'm going to take the 1 squared and take away this side. And when I square that, the square root goes away, and I get 1 minus x squared. Then the magic starts to happen, because when you actually simplify this down, you end up with just x. Now, I know some of you that are really smart know that it's the absolute value of x, but the length of a side on a triangle is a real thing. It can't be a negative, and unless we want to make this have two triangles in two different quadrants, which will add all kinds of complication, we don't want to do that. We'll just get x. And then, do you get, if this really all is x, that simplifies to an x. Then this side right here is an x. Then do you get sine of theta is x actually works? Because sine of this angle is the opposite over the hypotenuse. Okay, so this whole section is about this kind of problem. Let me give you another one that's simpler. Cosine of theta equals x. I just gave you all three sides of a right triangle. Try to figure out if cosine of theta equals x, what's sine of theta going to be? Draw a picture for me. Let's see if you can figure that out. Just to give you some hope. This is the last topic that we're going to do, so I'm going to give you a little bit more time to work. All right. Hopefully you knew to draw a triangle. Now, you could argue that there's two different triangles, but just from my experience, you can just do the one in the quadrant 1, and it's going to work out fine. Okay? Because really, we don't know whether x is negative or positive, and so it's just simplest, safest to draw it over there in the quadrant 1. So I like to put it over 1 because that helps me see I actually got two sides out of this. Cosine is adjacent and hypotenuse, so the adjacent side must be x and the hypotenuse side must be 1. And then this last side, square root of, do you get which one's bigger, the 1 or the x? One's got to be bigger because it's the hypotenuse. Okay, so 1 squared, I'll put squared just so you can see that, minus x squared. So that's what the third side is. So now, what is the sine of this unknown angle? It's opposite over hypotenuse. And so, some people wrongly think you can simplify that to 1 minus x. I can prove it's not right if you want, because I could just take, if this was 1 minus x, I could take this squared plus this squared, and it would have to actually for sure equal 1, and it doesn't. Because when you take this and you square it, you get a middle term. Okay, so bottom line, don't try to simplify the square root of 1 minus x squared into 1 minus x. This needs to stay as the square root of 1 minus x squared. Okay, so now the sine is opposite over hypotenuse, and you should have had opposite side from here is square root of 1 minus x squared. Over hypotenuse side is 1. There we go. That's what the sine of it is. All right. I think we did problems like this before, but it's been like at least a month since we've talked about this kind, where you have a variable for a side. So I wanted to talk that over with you. I looked ahead and saw that you will need that for the future. So, all right, so here's your assignment, and if since I did the first part for you already here, if you, as long as you copied that down, you're good. Just remember that this is right off the sheet, right? And we can use that same, it says sine equals x, so I can use that same exact triangle where sine is opposite over hypotenuse, and this other side must be square root of 1 squared minus x squared. There's my triangle. Verify, which means it's going to work. You just have to show that it works. That sine of 2 theta, which you can find right on your sheet, would equal this. Sine of 2 theta, right off the sheet, is, anybody have it memorized? 2 sine cosine. And we know what sine theta is. We can get it right from here. We know what cosine theta is. We can get it right from here. And then 2 times that, and it'll all work out to equal that. All right. So this one's kind of similar. X over 2. If sine is x over 2, I can draw my thing, and sine is opposite over hypotenuse, right? Opposite's x, hypotenuse is 2. You can figure out what this one has to be. Okay? All right. So if you didn't understand how to do 90 and 91, hopefully that little lesson about variables on the sides will help you. All right, so your assignment is to just finish up last night's homework. And then tomorrow, I'm going to teach you, basically the main thing is about tangent. We're going to do some graphs of tangent. Okay, that's all I got for you for today.